Hello students, we are now in chapter 11 and we shall be commencing with the subtopic 11.1 and 11.2 where we are going to talk mostly about the petrochemicals. These are the learning outcomes for these two subtopics. Firstly, we're going to look at the sources of fossil fuels, and then we're going to look what is crude oil. The most important part is in these subtopics, we're going to look at how to separate the crude oil into different forms using the fractional distillation as well as the catalytic cracking. First, we're going to look at the definition of organic compounds. We have already seen most of these definitions or the characteristic of organic compounds in chapter 10, so this is just a review for you. So what is the organic compounds? Organic compounds, they actually originate from the living things, and usually they have the covalent bonds between the carbon atoms, and then we know that some of the thousand of carbon atoms, they are linked in long chains. And the last one is that we have already also seen the definition of hydrocarbons. So hydrocarbon is actually the organic compounds that contain carbon and hydrogen only. Now we're going to look at the different type of fossil fuels and where we can find them. There are three types of fossil fuel. The first type of fossil fuel is called coal. So coal is actually a mixture of organic compounds. We can find them in the vegetation buried in ancient swamps. And then the second type of fossil fuel is called petroleum. The raw material of petroleum is the crude oil, where we're going to look further in detail after this. So what is petroleum? Petroleum is actually a mixture of organic compounds, and we can find them buried in ocean floor. The last type of fossil fuel is called as natural gas. Natural gas, they are mainly methane and butane with other hydrocarbon gases mixed together, and we can find the natural gas buried in ocean floor found with the petroleum. Now that we have seen the three types of fossil fuel, we're going to be focusing mainly on the crude oil. So we're going to look how crude oil looks like, and then we're going to see further in detail how they are processed from the raw material itself until we can use it into further uses industrially and domestically. Okay, so what is crude oil? You can see in the picture, crude oil, it is a dark, viscous, light liquid mixture of many different hydrocarbons. Okay, so you just need to imagine that there are many hydrocarbons contained in the mixture, which actually make it very concentrated, very viscous, and very dark. All right, so viscous in this context means that the liquid itself does not flow easily. And then we have already seen the hydrocarbons. It means that they are the organic compounds that contain hydrogen and carbon only. We know that the crude oil is actually the raw material of petroleum. Now the question is, how is it processed? So the crude oil, they can be split into fractions. What is fractions? Fraction means a group of compounds with similar boiling points. And the process that we're going to use in order for us to split the crude oil into different fractions, it is called as fractional distillation. Now we're going to look at how fractional distillation of crude oil look like. So the first step on how we can split the crude oil is that we need to heat the crude oil in a heater. Okay, so when the crude oil is already heated at certain boiling points, these mixture of hydrocarbons will be split into their different boiling points. And you can see that here in the fractioning column, they are already split into different fractions based on their boiling point. Okay, so the concept in this fractional distillation is that we're going to separate the petroleum into groups of compound with molecules of similar size, and then this is basically because the compounds have different boiling points. So if you take a look and on top of the fractioning column, you have basically the lowest boiling point. Okay, we can actually translate that into small molecules, okay, because small molecules, they have lower boiling point, and usually they are lighter in color, they are easy to light, and they are runny. But if you were to go down to the bottom of the fractioning column, you have the bitumen. So the ones that are placed on the bottom part of the fractioning column, usually they have higher boiling point, they are darker in color, hard to light, and they are very, very thick. Okay, and if you see here, we have like different fractions, right? Different fractions that have different usage domestically or industrially. So for example, for refinery gas, you can use it as a bottle gas, you can use it as the cooking gas at home. For petrol, you can use it for petrol for vehicles. Naphtha, usually it is used as chemicals. Kerosene, so kerosene, you can use it as jet fuel. Paraffin for lighting and heating. Diesel for fuel. Lubricating for oil, for lubricating oil, waxes, polishes. And then you have the fuel oil. So fuel oil, you can use it as fuel for ships, factories, and central heating. And the last one, we have the bitumen, where we use it for making roads or roofing. All right, so all of these fractions and their sequence in the fractioning column, you need to memorize them. How do you memorize them? You can use this formula. Okay, you have lovely people never kill dogs or fur babies. So lovely stands for the refinery gas. So refinery gas, we can call it as LPG as well. People stands for petrol. Naphtha, never stands for naphtha. And then kill stands for kerosene. Diesel, dog stands for diesel. And then you have or, it stands for lubricating oil. Fur stands for fuel oil, and babies stands for bitumen. Okay, so please take note that this one you need to know in order for you to answer, especially paper 2 or paper 4 in IGCSE. We have seen the process of fractional distillation, and we have seen the different fractions that we can get from this process. Now we're going to look at what happens to these fractions. Now, the fractions, they are still a mixture of more long chain hydrocarbons. These longer molecules from the fractional distillation, they can be broken down into smaller molecules. This process is known as cracking. For example, we can crack the diesel into petrol and aviation fuel for which there is a greater demand. And we can also produce ethene, which is needed for making plastic. Cracking, how is it done? Larger hydrocarbons, they are vaporized, which means they are turned into gas, and the vapors are passed over hot catalysts. Alright, so these are the two conditions that we need in order for us to do the cracking. So first, we need heating. Okay, so we need heat in order for the larger hydrocarbons can be vaporized into gas. And the second one, we need the catalyst, right? So after we have already put these two conditions together, we will be able to crack the larger molecules into smaller molecules. So we have an example here where we have decane, which after the cracking they are being broken down. So decane, it is being broken down into propene and heptane. Okay, so remark here, please be careful. You need to count up the carbons and hydrocarbons before and after. They should always be equal. All right. So usually you will see that here after you crack one of the alkanes, a long alkane, you will see that you will have always, usually, you will get an alkene and you will get an alkane or hydrogen gas. We're going to look at some of the examples in the next slide. So we have few examples here. First we have ethane, okay, and we're going to try to crack ethane into alkene. All right, so what is the chemical formula for alkene or ethene? So ethene is C2H4. If you were to do the calculation, you subtract the number of carbon, C2 minus C2, you will have none of the carbon left. But for hydrogen, H6 minus H4, you will get another one product, which is hydrogen. All right. Okay, now we're going to look at the second example. We have propane. For example, propane, you have C3H8. So you can do like the first example. Okay, for example, you want to get propene. So propene is H3H6 plus H2, because when you do the subtractions, you will get another H2. And you will get another alternative to this cracking. You can do, for example, you will get the ethene, C2H4, and then when you do the subtraction, C3 minus C2, you will get C only, and H8 minus H4, you will get H4. Okay, so here in this case, you will have ethene plus methane. Okay, all right, we're going to look at the final example, which is butane. All right, you can do as the previous ones. For example, you want to get butene. So butene, it's always C4H8 plus H2. And then you can try to get, for example, propene. So propene is C3H6. And then if you do the subtraction, you will get methane. Or you can also get, if you want, ethene. So ethene is C2H4. So if you do the subtraction, you will get C2H6. So in this case, you will get ethene plus ethane. All right. So bear in mind, in cracking, there will be a lot of alternative. Okay, for you to get, you will get a lot of examples or answers if you want. Okay. Alright, so the last part with the fossil fuels, we're going to talk about the combustions of these fuels, which is actually a problem to us. Okay, so in this case, we're going to try to write down the equation on the combustion. So we know that for combustion, the products will be always carbon dioxide and water. For example, I'm going to put methane because this is the easiest one. And then for combustion, in order for the combustion to happen, we need the oxygen, and then we shall get the carbon dioxide and water. Okay, so if we were to balance this chemical equation, we need to balance the number of atoms left and right. So carbon is one left and one right side, so it's already balanced. And then if we were to balance the hydrogen, here we have 4, here you have 2, so we need to balance 2 in front of the water. So hydrogen already balanced. So now we just need to balance the oxygen. So 2 times 1 is 2 oxygen. And then here we have 2 as well. So 2 plus 2 is equal to 4, which means here in front of the oxygen we need to put 2. Alright, so that's it for the subtopic 11.1 and 11.2. Should you have any questions, please do not hesitate to direct them to me. We shall be resuming with the another video where we will be talking further on the subtopic 11.3 and 11.4, where we will be focusing more on the polymers and the polymerization.